The first learning objective in section 6.5 is to determine whether a significant linear relationship exists by using a t-test on the slope. In a study of feeding behavior, zoologists recorded the number of grunts of a warthog feeding by a lake in the 15-minute period following the addition of food. The data showing the number of grunts and the age of the warthog in days are listed below. Use technology to compute the test statistic and p-value on the slope of the regression line. Use your results and alpha equals 0.05 to determine whether a significant linear relationship exists. When we're doing a t-test on slope, the null hypothesis is that the slope, that's our beta 1 coefficient, equals 0, versus the alternative hypothesis that the slope is not equal to 0. A slope of 0 means that the scatter plot would look something like this, and the line going through the middle of the points would be horizontal. Notice that no matter what the value of x is, y is about the same thing. In other words, there's no relationship between the two variables. Knowing what the value of x is does not influence what the value of y is. For this particular example, we'll use the number of grunts as our x variable and the age as our y variable. So we go along, we hear a warthog grunting, and we count the number of grunts, and we're wondering if we can predict how old that warthog is. It may make sense to switch the x and the y variables, but in order to just test whether there's a significant linear relationship, it doesn't actually matter which variable is the explanatory variable, which is the response variable. We're just looking to see if there is a slope that is different from 0. If the slope is different from 0, it means it's either positive or negative, which means that as x is changing, y is also changing. That means there is a relationship between the two variables. In order to compute a t-test on the slope, we will use the app that is in our Canvas course, the t-test for simple linear regression model. In this app, we enter the data. So I've entered in the number of grunts in column A and the age in days in column B. And the output gives us several different things, but what we're interested in are these two values here. The t-stat is the test statistic for the t-test on slope, and the p-value is the p-value for that test. So our test statistic is a t of negative 3.43, and our p-value is 0.01092. Using this p-value, we can compare it to our alpha of 0.05. This p-value is less than the alpha of 0.05, so therefore we would reject the null hypothesis that the slope is equal to 0, meaning that there is no relationship between the two variables, and we would have sufficient evidence to conclude that the alternative hypothesis is true. In other words, there is a significant linear relationship between number of grunts and age in days. Here's how it might be worded. Since the p-value is less than alpha equals 0.05, there is sufficient evidence to conclude that there is a significant linear relationship between number of grunts and age in days for warthogs.